Section 3.1, title is Angles.
What the heck?
An angle, in essence, angles you guys are used to seeing or dealing with. As you sit here and you have this line, then somewhere it stops, or a segment. Then it stops, right? Then what does it do at that point where it stops to make an angle? Does anybody describe that? Another segment starts
Where it's
going a different direction, maybe?
Or it's 90 degrees.
Right, so maybe now it goes this way. Okay? That would be an example of an angle, would it not?
Yeah.
Does everyone agree?
Yes.
Okay. So basically this segment went this way and then it got to somewhere and then it changed directions. I'm sick of you guys talking back there. Look up here. This point where it changes direction is called the vertex. Okay? Vertex is a very important point. Now, does anybody see on this piece of paper what I have here? Does anybody see at the end of these things what does this end of this look like? It's rounded off, isn't it? In a way, is it not half of a circle? Would you guys agree? Okay. That's how you measure angles, along a circle. Right, Damon? Everybody look up here. Measure it along a circle. Now, what you do with this one is you see how I put the vertex right on that circle, right there. Does everybody see that? Now this thing is kind of a tool it's made to be a little bit of everything. It's made to be a ruler, made to be a protractor, made to be a compass all in one. That way you won't have to carry around 3 different things. To make this one work, you line that up on the vertex and then see the 180 right there? You line it up on the line. When I've done that, I can now measure this angle. Now, one thing to look at here. It has 2 sets of numbers, doesn't it? It has 180 right here, and then it has going 10, 30, 50, so on, doesn't it? Everyone agree?
Yeah.
Which numbers do you think I ought to use?
The black one.
Well, the black ones are here. Does it make sense that an angle that went to right here would be a 180-degree angle? That would probably be 0, wouldn't it? And see, as it gets bigger, as the circle, it gets... So here, we're going to use the red numbers. Okay? I'll show you why they have the black numbers here in just a second. So this is 10 degrees, 20 degrees, 30 degrees, 40 degrees, 50 degrees. Wow, I drew a 60-degree angle. And you know, it's measured along a circle, isn't it? Okay? Now, watch how if I turn this over, and now I use that vertex, and now I go over here.
Bless you.
Now does it start at 0? What do you get using the black numbers? 60 again. So what it is it's left or right, so you don't get stuck always having to have the line on the what? Right or the line on the what?
Left.
You just need to remember you're always starting at 0 here. So from here to here obviously wouldn't be a 120-degree angle, would it? Obviously it's what? 60. So that's how you use these. Does that make sense? Do we kind of understand the way an angle is measured? Okay, it's measured along a circle that way. That's how we measure an angle. One of the most important things that you will learn is how we name an angle. This is another one of those things that will seem like a different language. For instance, this angle, I'm going to put a little 1 right here, okay?
Bless you.
It could be named 3 possible ways. And not all angles can be named 3 possible ways. First way, I can name it by using points on it, and I name it as I would draw it. If I was to start at A and draw this angle, I would say angle, I would start at what? A. Then where would I go next?
B.
B. And then where would I go next?
C.
You name it as you draw it. But what's the other way I could also name it? I could start at C, B, A. Can you see, though, that you could not name it angle, everybody look, B, A, C? Because would I draw this angle when I did that?
No, you know.
I'm drawing a different angle, aren't I?
Yeah.
So what do you think's always in the middle?
B.
Be what?
Vertex.
Vertex, where it changes direction. Okay, because basically you're going to name a point on one side. This is called a side of the angle. You're going to go to the vertex, to the point where it changes directions, and then you're going to go to another point on it. So that's one way you could. Okay? In this case, there's actually another way. You could just name this angle B, using its vertex. However, I caution you to this. You can't always do that. The reason you can here, if I said angle B, would there be any, would you wonder which angle I was talking about? You wouldn't, would you? But, and don't write this down, if I was to draw this, because I'm going to erase it right quick, if this was the picture I was referring to, and I said, how much does angle B, what's the measure of angle B? Courtney, just pay attention up here. Would you know what angle I was talking about?
No.
Because at this vertex, couldn't it may be this angle, right? It could be that angle, or believe it or not, it could be that whole big angle too, couldn't it? There's 3 different angles that could be angle B, couldn't they? However, on this one, there's only one angle that has B as a vertex, so I can name it angle what?
B.
You see the difference? So this we can only use sometimes, right? And you guys ought to be able to look at a picture and say, and ask yourself that question. If I said angle B, would he know which angle, is there any other angle that he could think was angle B? And if there isn't, then you can do that. Third way is sometimes they'll put a number right here, 1, 2, or 3. Obviously, that's not a 1 degree angle. Agreed?
Mm-hmm.
So they'll say angle 1. This is very handy when you have a bunch of angles together, and that's angle 1, angle 2, angle 3, angle 4, angle 5, so on and so on. Okay? Now, I'm going to draw a point here, point D, and then I'm going to draw another point here, point E, on our picture. Name an angle, or name, I'm sorry, name a, can't believe I said angle, name a point on the angle, the interior of the angle and on the exterior of the angle. Name a point on the angle, on the interior of the angle, and exterior. Where do you think the interior of this angle is?
On the inside.
It's the side enclosed by it. Okay, in a way, I guess you could say there's an angle like this too, right? It's the smaller one. So this is the interior of the angle, isn't it? So what is a point on the interior? Name me a point in the interior of this angle. Huh?
D.
D. Point D. Now, what about on? That's actually on the angle, on those rays that are on it. So, there's three choices. You could put A or what?
B.
B or what?
C.
Name me a point on the exterior, or in the exterior, E. It's outside, isn't it?
Oh,
This is all the exterior, isn't it? Okay? Easy enough, isn't it?
It looks like Pac-Man, sort of.
Yeah, it does. And this is another one of those easier lessons where, in essence, we're learning a vocabulary lesson. This, believe it or not, right here,
It's an angle.
is one of the most important angles you'll deal with all year. It is called a straight angle. These here are called opposite rays. BC, ray BC, and ray what? What other ray? BA are opposite rays. Why? Because they go directly the opposite direction from and they make a straight line. The measure of a straight angle will always be curious if you guys can answer that question. Well, let's measure. It's 180 degrees, isn't it? Right, Damon? So anytime, and can you look at a picture and tell whether something is a straight angle? This is one of the few things in geometry you can look at and say, that's 180. So don't write this down. So if I was to make B to D here, what do you think this angle plus this angle would be? You guys, you'd be amazed at how much you'll use that this year. Two angles that together make a straight line, or three angles. This angle, if this was angle 1, this is angle 2, this is angle 3, what do you think Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. What does it got to be? 180. You can look at a picture and see that. You don't need to be told that. That's something from this point on you're going to have to know. It'll get used over and over and over and over again.
Oh, is that necessary?
Quiet, please. Please don't comment on that. If I put another one, angle 1 plus angle 2 plus angle 3 plus angle 4 would equal what? 180. That's simple, isn't it? But you'd be amazed at how many forget that. You will use this over and over and over and over again. You have to remember that a straight line makes a 180-degree angle. Even though it doesn't look like an angle, because here I was talking about an angle is where it goes, it gets to the vertex, and then it what? Changes directions, right? This is the one angle that it goes, gets to the vertex, and then it does what? It does not change directions, does it?
No.
Make sense? That's why people are, it's weird for people to think that this, which you can write this down, has to be 180 degrees. Very, very, very important. Something you will use over and over and over again. Now, get out the 3-1 worksheet. Let's do some examples before we start our assignment. We will do 3-2 tomorrow because I won't be here for some of the hour Monday morning. Name each angle in 4 ways.
Element.
It's angle. Now, see this little sign here? You have to say that. If you say just LMN, I think you're talking about a plane. So you have to say, this is saying the word angle, L-M-N. What's another way to say it? Angle what? N-M-L. I could also say angle what? M. And then there's one more way. Angle what?
7.
Okay? You guys okay with that? Do we need to do the other two?
No, that's it.
Okay. And like I said, this is a vocabulary. Name all the angles that have Q as their vertex.
UQW.
Very good. We kind of started with the hardest one probably there to see. That's the whole big angle. One of the things, guys, look right here, that you'll see is some people have problems seeing that angle. You know, the angle that doesn't include that, right? The big angle without the one in the middle. That one does exist. So angle UQW.
UQV.
You can do UQV, or you could say angle what?
1.
And here you could say angle what?
2.
But if the thing that, whether you know you're right, is if you do use the letters, what letter has to be in the middle for it to be Q? Because that's the vertex. Here, what angles are there? Angle what? X, Q, Z, angle 3, and angle 4, right? Or you could say angle X, Q, Y, and angle Y, Q, Z. This one, there's going to be one more. It's going to be angle AQD, angle 5, angle 6, angle 7. Now, you say, why don't we use numbers all the time to name these? Because it's so much easier to write down. It's so much easier to see which angle you're talking about. It's for this reason right here. In all 3 of these problems, could we name every angle using a number?
Yes.
No.
No.
No. Not
Which
the-
one could we not?
The biggest The one.
The biggest one, because where are you going to put the 3? Right there? That would be confusing, wouldn't it? You wouldn't really, you know, if there's, you want there to be no doubt we know what you're talking about. So each time the big angle that had all the little angles in between it, we had to use what? The only way to name it, the only way that works every time is that way. The just naming the vertex like we did up here for this, or using numbers only works some of the times. The only way that can work every time for every angle is those. I don't think, can you guys, this one, interior, exterior, on?
Interior.
Interior, here, exterior,
Exterior. On.
Interior.
on. 9 is on, here,
Interior.
Oh, is it unsaid?
interior.
On. Exterior.
Tell whether each statement is true or false. The vertex is in the exterior of the angle.
False.
False, vertex is what? On it.
On one.
Angle ABC, angle CBA, and angle B are the same angle.
Yes.
Why?
Because they all have the same.
They're in opposite order, and they all talk, okay, 3 rays are necessary to determine an angle.
False.
How many rays do you need?
2.
Two.
That needs to be 2. That needs to be on. Okay?